I would like to introduce you to a methodology that we are using to generate coherence between the schemes under the framework. And I will come to this, of course, in a minute, and also talk about the benefits. And finally, I have also some remarks concerning standards and standardization. Let us go into the subject. So, as was already explained in the panel, the Cybersecurity Act is the foundation for a European cybersecurity certification framework, which is intended to increase trust and security and help to establish a digital single market. So a single market, of course, then also means that all layers of the ICT market should be included, that the schemes under this framework should be coherent so that, for instance, reuse of certificates is possible. And you also heard that the application of these schemes is voluntarily, and this means, of course, that we have to take care, that the market will accept them and to design our schemes accordingly. The Cybersecurity Act itself gets a bit more precise on this and stipulates requirements which target exactly this direction. So first of all, there is the requirement for having a risk-based identification of security and certification requirements associated with the intended use of the particular products, processes, and services. The same applies for assurance levels and their definition. There should be also methods in place which support security by design and the association of security technical controls to assurance levels. And last but not least, and this is probably the key, for having the opportunity to reuse certificates, is a consistent implementation of assurance levels across these schemes. So the methodologies that I would like now to introduce to shall support these goals in the context of sectoral candidates cybersecurity certification schemes. What this means, I will explain in a minute. So the project is almost finalized. We have worked on this topic with quite well-known and experienced experts from Europe over the last few months. So we have now a draft report available and can look into the first trial of this methodology. And this trial should take place in the workflow of how we do the drafting of candidate schemes, which is defined in the Cybersecurity Act. If you would like to know more about this, please consult the ENISA's website. Here you will find this picture and an explanation to it. And our proposed methodology is seen as a preparatory step of the drafting of sectoral schemes. So we will do certain assessments and work out certain information, as I will describe in a minute, that will help the drafting of sectoral schemes. The approach to define this methodology is the following. So first of all, we try to understand what are sectoral schemes and what do we have to do and to structure our work in order to support sectoral certification schemes. An essential step was, of course, also to identify the standards that we wanted to use, and enable the information exchange between standards and potentially also to bridge gaps. As the name of the methodology says, risk assessment is certainly a key topic, and the idea is to do this risk assessment at the top level in order to get comprehensive information about the sectoral system, including the underlying layers. And the idea was also to enhance this, to complement the classical risk assessment with cyber threat intelligence and the use of threat landscapes. You may know that ENISA has done some work in this area and can contribute to this. So the goal is to have a sound understanding, including also information on attackers and their attack potential. The fourth step is related to maybe the core of this methodology, how to combine consistency of the across implementation of assurance in several schemes with a certain flexibility as it would be required to follow market needs for the implementation of schemes. And on top of that, to combine this with a risk-based approach to the definition of security and assurance requirements. So one of our principles when doing this was to use standards. You know that evaluation certification is about trust, is about confidence that security was properly implemented. And so we see a lot of commonalities between certification and standards, open standards, international standards. And we try to use these as far as possible. And we see them as our stepstones for generating trust and confidence also into this new methodology. So let us have now a look at a typical sectoral ICT service system. So if you have now see this upper part, let me point you first of all to this blue bubble. So this should symbolize several roles, several stakeholders in the sectoral environment. If you, for instance, look at the health sector, you know this ICT service provider could be an entity or a stakeholder who provides a patient file service to end users and has a direct relationship to these end users. But there are also supporting roles which are necessary to work with this service provider, for instance, hospitals or medical practitioners, or also health insurance organizations. And in many cases, these sectoral organizations can be quite huge and complex. There can be many stakeholders. Some of them may even be competing with each other. And therefore, you need sort of an entity that coordinates this. And we call this here the coordinating entity. It could be a governmental org, or it could also be an body which was established by the sector and its players. So we have examples for both of these cases in the field. The interesting thing is now that certain things are out of reach of these of the sector and also the coordinating entity. So we have very likely certain infrastructures which are used by a sector, like a network service or ID services or payment services. And we also, on top of that, even in the lower layer, sectors typically make use of generic, or you could also call it horizontal products, which are simply used by the sector for their purposes, like a smart card or also like a smartphone, you know, where the app is then just put onto this platform. So the question is now that we had to answer: how can we put all this into one scheme? How can we live? You know, how can we deal with this complexity? And make sure that a certification process can be successful. And the simple answer is, if you put everything in one scheme, it will hardly work. The key is to have a structuring, a layering structure of such sectoral schemes and systems. So the idea would be to have a sectoral scheme, which is sort of the umbrella scheme, which covers certain sectoral processes, but in mainly references the certificates and relies on the schemes of the underlying layers. So in particular, this would be that a sectoral scheme, which, as I said, you know, there can be hundreds of organizations in such a sector, and to rely on the ISMS certifications of these particular sectoral organizations. Further on, it could be an idea to have the infrastructures and products certified by their particular schemes. And in the end, the sectoral scheme would just collect all these certificates from these underlying schemes, and perform the certification in this manner. So such a layered approach, of course, requires that all these schemes can be linked, so that terminology and the implementation of key parameters like assurance are harmonized or at least comparable, that you know what you're talking about on the various layers. It is also very important that the intended use can, of course, only be identified, you know, on the sectoral or the infrastructure layer. that these sectoral requirements and the information related to the intended use can be properly communicated to the lower layers, so that these know what to do and report back if what they do fits into the sectoral environment. So this is the starting point of our considerations, and from there we took then some steps to make this happen and establish a methodology that can deal with this. And in fact, the first task that we took on our list was to see how can we now enable this information exchange because between our two main standards that we identified if we look at the sectoral level and the underlying layers, which is the 27000 series and the 15408 series, including 18045. So you know all that these families of standards are not for the same purpose. And so it's no wonder, no surprise that certain terminology divergences exist. So we make a list out of we made a list out of these divergences and explained them, tried to explain them, documented the meanings, and on this basis we would now be able, to transfer information properly from one standardization family into the other. So this is how we can show this in a view graph. So you see here on the left-hand side the classical process for the risk assessment, including establishing the context, which is then carried out at the sectoral top level, and how information can then be transferred into the security problem definition and the SFRs and SIRs in the definition of the product. And here you find the mapping symbolized. The next challenge that we face is how to drill down into a sectoral system risk assessment to get the intended use documented of the particular products, services, and processes. So we use here a very classical approach. We started with the asset analysis, first on the business level, drilling then down to the identification of primary information assets. Having this done, with the knowledge of the security architecture, then of course also the ICT products, ICT services and processes and also the sectoral ISMSs, which supports these primary information assets. We call these then supporting assets. And then we continued plan to continue the risk assessment at the supporting asset layer in order to document the intended use or the operational environment of the particular parts. I mentioned CTI in the introduction, and yes, we are using also cyber intelligence in these two steps. The purpose is to identify, first of all, the relevant attacker types, and based on then also on the context of the sector, based on sectoral threat landscape, and to see what attack potential we can relate to these attacker types. We do this for the primary asset layer, and here the information will go into the risk assumption. And on this, also on the supporting asset layer, so one layer down, we can then have a closer look, which, this is the terminology in CTI, opportunity and means, are related to a potential attacker type with regards to a certain type of product. So this brings us the information that we wanted to have to be able to determine risk based on the intended use, and also to define security and assurance based on the intended use and the risk related. So now coming to the maybe most challenging part, how to get this combination done between flexibility of schemes and the need to introduce various kinds of evaluation methodologies in order to support different market needs, and on the other hand, to have comparison in the implementation of assurance and security. So this is exactly what we try to have by having a common reference, not just following one standard and trying to adapt all others to this. And the goal, as you see here on this slide, is to have of course, also first of all the EU schemes, which are now under discussion or in development, involved in this or integrated into this, but also then classical CC, also probably industry lightweight, or hopefully at a certain point in time also ISMS-based schemes, in order to have a broad coverage as possible. And of course, in the end, it should be possible to map these to the 3 assurance levels defined in the Cybersecurity Act: basic, substantial, and high. So how do we try to achieve consistency? So what we introduce, and I will show this in a picture on the next slide, is to we introduce level concepts for 4 parameters. For risk, we call it meta risk class. For the attack potential, for the security level, we call it common security levels. And so we choose also the assurance levels. We call it common assurance reference for internal uses. And all these, and this is the idea, have default relationships. As the Cybersecurity Act says, assurance and security should be based on risk, and this is what we implemented. The flexibility is achieved because we, when we look at schemes and the implementation of assurance, we will not strictly require conformity. We will just look for a common denominator. And of course, this would then need some individual considerations in every case. We will also have the opportunity to support the stakeholders' risk appetite. I will show this in a minute. And also to support exceptions from the default relationships. So now coming to a bit more complex picture. I don't want to go into the details, but just to show the principle. On the left-hand side, you see the classical risk assessment, resulting then in several risks to be looked at based on impact and probability or likelihood. We add here information on attackers, and all this is then described in our in the report that we generated on how we propose to bring CTI together with this information. But the idea is, to have the stakeholders themselves mapping these their perception of risk and the potential impact of certain attack potential into these meta risk classes. There are 5 of them. So the stakeholders could decide by themselves, how to map their risk perception into meta risk classes. And from there on, as soon as these meta risk classes have been selected, there is per default a one-to-one relationship. So in meta risk class 2 would go into common security level 2. Except for the case that there is an attack potential which exceeds the risk level. And so in this case, there's a suggestion to adopt the common security the common security level accordingly. So this is a very, very simple algorithm that we propose for this selection, and we use a similar approach if it comes to assurance. And so we have here the same principle for the identification of meta risk class per risk. So it's in fact there will be in both cases the same meta risk class selected. Also here we have a direct relationship, default relationship to the commercial assurance reference. Also here we have the relation to the attack potential. And so this also explains what the relationship between assurance and security in our model is. It is indirectly via the meta risk classes, and of course also considering then the attack potential. So this is the basic idea that we will try out in first implementations probably as soon as they come along. And if you look at the functional model, it looks like this. So on the left-hand side, we have the sectoral system, and we do the sectoral risk assessment here from the top level. The gray boxes here indicate that risk assessment and cyber threat intelligence are blocks that we are simply reusing. There's nothing that we changed or added to what you find in the standards. The yellow boxes indicate that we have that we use the output from these two boxes to define something new. And in fact, the classification of risk, the selection of the common security levels and common assurance references, and also the documentation of requirements and the intended use, the operational environment of products, processes, and services. So in the definition of common security layers also gives us the opportunity to define some examples for controls which are scaled with regards to their strengths according to this concept. So we did this, and these could potentially then be used in the implementation of in the product or in the organizational ISMS to make this easier and also to support the idea of security by design. Here, of course, you also see the mapping boxes, because on the left-hand side, we are in the ISO 27000 world, while in the product world, we have to translate into the 15408 world. So this is the basic the overview on the methodology. Of course, there may be a lot of questions related to this. But let me just also give you an overview on what we think the Fspc benefits can be that such an overall approach that comes from the top and includes also the lower layers can bring. There are potentially new options which simply arise due to the fact that there's now a very good understanding of the system and its security features and requirements. Also, we think that the underpinning of the classical risk and information helps a lot to define assurance and security levels properly. It could potentially also help to compare assurance across schemes. As said, we hope that we have now a good compromise between flexibility and coherence and consistency implemented, so that schemes have the flexibility to deal with market requirements. On the other hand, there is the possibility to reuse certificates. In terms of market acceptance, we think it's very important to have to note that stakeholders will be involved in the identification of risks, and they will also be able to categorize risk. So they have insights on how this is done. They can also influence the process and participate in the balancing of their perception of risk and the cost of security that implementation will have. I think this is a very strong point, if it comes to market acceptance of the scheme. Product suppliers told us that they would really appreciate to have more information about the precise risk requirements from their sectoral customers and the intended use of their products. So this would help them to be more efficient in their development process, and also give them more confidence that design-ins into certain sectors will be successful. And last but not least, if I may mention this, take in 1 or 2 minutes. We see also a chance to solve or to help solving an issue which occurs if you cannot exactly implement the security level that you would need in particular parts of the system. So examples may be low-cost devices, IoT devices, where you have simply limitations for the implementation of security for cost reasons. Or another example could be something like a smartphone, where you simply do not exactly know what the security or assurance level is, and where you also have no chance to make this part of your certification process. So here, this sound understanding and of the entire system, and also the relationships between the stakeholders would allow to distribute tasks with regards to deployment of controls. So you could compensate by certain deficiencies in some areas, potentially by adding controls in some other parts where it is easier possible. So, for instance, in the back office, if you do not have the chance to deploy certain controls in the customer front end. I think this is something that can also be now envisioned. What is the observation now if it comes to using standards and just getting a bit more precise now about the overall contents and purpose of this conference? I think it's pretty clear that, and this is also why I mentioned this initially in my first slide, that the goal would be to have a single market with non-discriminatory access of technology on service providers, and of course also enabling then choices for customers by competition. So and this requires an open architecture, and open standards are the basis for any open architecture. Also, and I have here a good example, since I worked until last year in the area of transportation, also on mobility as a service in ISO TC 204. There is, especially when we look at the European situation, it is often necessary to team up a lot of sectoral organizations from the regions or also on the national scale, to build service offers and market reach that can compete with international giants. This, of course, if you have to bring together many stakeholders who work together, some of them may even be competing, requires that you ensure interoperability and that you have a common approach to security. And here is where standardization and certification comes into the game. It is simply indispensable. So the availability of open standards for such an implementation and also for the interoperability testing are prerequisites for such open systems. Certification is typically required for interoperability, but also for assuring a specified minimum level of security. And in particular also to establish trust between the participating stakeholders, and which may potentially be competing. So there's clearly a big dependency on what we try to do in the sectoral area in terms of cybersecurity certification, on what you can provide, and that's very, very promising and good to hear what you have on your agenda. And if you allow me, despite all this very good work that we can now use, there may be some remarks, on things that could be very, very beneficial, and substitute these first steps into solutions that we try to find by more professional ones, which are then also given in international or European standards. So the first point, which is not on this list, but I would like to mention this explicitly, would be to standardize cyber threat intelligence. I think this would be very helpful. So far, there is not much that we could find in open standards. So we mainly reused 27000 terminology for this. It would, of course, also be good, to have some standard interfaces between the 27000 and 15408 families for information or of exchange on risk and operational environment and so on. It would also be good to understand how the standardization experts could see potential enhancement of the ISMS world into defined security and assurance levels, or even come to an evaluation methodology that would support this in the ISMS world. And last but not least, you saw that we are using several standard families at the same time, and potentially these will be referenced by the cybersecurity certification schemes. And as you know, the cybersecurity certification schemes underlie a certain maintenance cycle. It would be very good, to have a sort of synchronization between these life cycles and maintenance cycles, because otherwise the referencing could be a bit difficult. So this is, my final slide, and I would like to thank you for the very, very good work. Without what was done so far, and also in future in SC27, we could definitely not have done our job in this way.